Hello dear students, I welcome you to this video channel. I am Dr. Yusuf Hanif Sheikh, Associate Professor, Department of Physics, Shivaji College, Kannada. Today I am going to teach you characteristics of a junction field effect transistor, that is JFET. A junction field effect transistor has three terminals, namely source, drain and gate, but any electronic circuit of a device require two terminals for the input and two terminals for the output. Therefore, one terminal of the junction field effect transistor has to be made common between the input and output so as to use it as a circuit element. Hence, a junction field effect transistor can be connected in the following two ways: the common source configuration and the other common drain configuration, or the source follower configuration. However, the commonly used configuration is the common source configuration. Hence, here we will discuss the characteristics in the common characteristics in this configuration only. The figure in this slide shows the circuit diagram for determining the static characteristics of a n-channel JFET in common source configuration. The supply voltage VGG provides reverse bias VGS across the gate source. A voltmeter is conducted across a gate and source terminals for measuring gate source voltage VGS. A supply voltage VDD provides a voltage across drain source VDS. A voltmeter of sufficient range is connected across the drain source terminals to measure the drain source voltage VDS, and a milliammeter is connected in series with the drain to measure the drain current ID. To study the characteristics of the field effect transistor, either the gate source voltage VGS or the drain source voltage VDS is to be kept constant. Hence, there result two types of characteristics known as output characteristics and the transfer or mutual characteristics. Output characteristics. The output characteristics for n-channel field effect transistor in a common source configuration is as shown in figure in this slide. The characteristics are also known as the drain characteristics. These characteristics represents variation as shown in figure in this slide. Drain source characteristics of the FET of a drain current ID with variations in the drain source voltage VDS or constant gate source voltage VGS when VGS is equal to 0. The channel is entirely open with VDS is equal to 0. No current flows from drain to source due to the absence of attracting potential at the drain for the majority carriers. For a small value of VDS, the semiconductor bar acts as a simple resistance and the current ID increases linearly with VDS. Due to the flow of current through the semiconductor, ohmic potential drop is caused, which reverse bias the gate junctions. This increases the width of the depletion region and reduces the channel width. Due to the ohmic potential drop across the length of the channel itself, the reverse biasing of the gate junction is not uniform over the length of the channel. The width of the channel is more near the source and then at a distance point from the source as shown in the figure in this slide. As the applied voltage is further increased above a certain voltage, the current is known as the saturation current and the potential is known as the pinch off voltage, denoted by Vp. Even beyond the pinch off voltage, the channel is not completely closed. Consequently, current is not reduced to 0. Further increase in voltage VDS increases the reverse bias on the junction, resulting into a avalanche breakdown of the gate junction. Because of the drain current shoots up rapidly as the drain voltage adds to the bias at the gate. The saturation current is maximum with VGS equal to 0 and is designated as IDSS. If the reverse bias across the gate junction is increased, saturation current decreases as shown in this figure in this slide. Transfer or mutual characteristics. Another junction field effect transistor characteristics is the transfer characteristics. The transfer characteristics are the variations of the drain current ID with variations in the gate source voltage VGS. For a constant value of drain source voltage VGS greater than Vp, these characteristics, also called as the transconductance characteristics, are obtained directly as shown in figure in this slide, or from the drain characteristics by reading the values of ID and VGS. The transconductance curve of the JFET is as shown in the figure in this slide. The characteristics indicates that as VGS increases, the drain current decreases. The two important points on the curve are IDSS, the saturation current, and VGS equal to 0, and 15, the voltage at which the drain current becomes 0. The transfer characteristics is parabolic curve, which can be algebraically represented by the equation ID equal to IDSS into the bracket 1 minus VGS upon VP bracket raised to 2. FET parameters. In a field effect transistor, the drain characteristics ID depends on the drain source voltage VDS and the gate source voltage VGS. Thus, keeping any one of these variables constant, the relation between the two other variables is found. The various parameters of FET can be obtained from its characteristics curves. The main parameter for FET in common source configurations are defined as drain resistance. For low values of drain source voltage, the variation of the drain current are quite linear, with the gate source voltage being constant. Thus, the FET can be considered as a simple resistance, and this resistance is known as a drain resistance, denoted by RD. It is defined as the ratio of the small change in drain source voltage to the resulting change in the drain current when gate source voltage is constant. Thus, RD is equal to delta VDS upon delta ID at constant VGS. The drain resistance can be obtained from the output characteristics of FET. It is given by the reciprocal of the slope of output characteristics. Clear that the value of RD is very high and constant in the pinch off region. In the ohmic region, it is low and varies from 10 to few hundred ohms and is denoted by a VGS and is dependent on VGS. Now, the second character is transconductance. As explained earlier, the drain varies with fluctuation in gate source voltage. When the drain source voltage is kept constant, the parameter relating this variation is called as transconductance or mutual conductance, denoted by GM or GFS. It is defined as the ratio of a small change in drain current to the corresponding change in the gate source voltage at a constant drain source voltage. Thus, Gm is equal to delta ID upon delta VGS at constant VDS. The transconductance can be obtained from the transfer characteristics. It is given by the slope of the transfer characteristics. The transconductance calculated at ID is equal to IDSS is called as G mu. Now, the third characteristics, amplification factor. The amplification factor of a FET is defined as the ratio of change in the drain source voltage to the corresponding change in the gate source voltage at constant drain current. Thus, mu is equal to minus delta VDS upon delta VGS at constant ID. The minus sign here indicates that when the drain source voltage is increased, the gate source voltage has to be increased so as to keep the drain current constant. From the above equations, it can easily be shown that mu is equal to Gm into RD. And thank you, dear students, for your patient listening. See you again in the next video. Till then, bye bye.